Okay, so we're going to be looking at restrictions of rational functions. So recall, rational functions are functions that are fractions. So we see some examples below here. And one really important thing when dealing with fractions, especially when there's variables in the denominator, is that we have to remember that we cannot divide by 0. And that's where restrictions come in. So we cannot divide by 0. If you take out your calculator and you type in 1 divided by 0 or anything divided by 0, it'll likely say undefined or math error or something along those lines. It won't give you a number answer. And if it does, your calculator's broken. Okay, so since we can't divide by 0, we have to restrict, hence restrictions, some of the values in the denominator of our variables. So we can't divide by 0. So we must restrict the value of some variables. It's usually going to be x, but it's not always. Some variables to avoid division by 0. Okay. So that's our goal. So for each of these questions, we're going to write down some restrictions. So we're going to write over here, off to the side here, say restriction. We'll make a little list of our restrictions from our first function here. So if we look at this one, we want to make sure we know what value of x will make the denominator, the bottom here, 0. So we're really just focusing in on the bottom here. Okay, so we can't have a 0 on the bottom. So we might say, x minus 2 cannot equal 0. If it equals 0, we have a problem. We want to avoid these problems. Okay, so now what value of x would make this part 0? Well, you could probably just guess, or you see it and you see, oh, if I plug in positive 2, I get negative 2, or 2 minus 2, and then that's 0. That'd be our restriction, which is true. We can also just algebraically rearrange this. So we can bring the 2 over and say x cannot equal 2. And that's our restriction for this question. X cannot equal 2. All right, let's look at the next one. So here we have two things. So we might say, y minus 3 cannot equal 0. Also, y plus 4 cannot equal 0. So this goes back to solving quadratics. Right? This is kind of a quadratic. It's already factored for us, really, on the denominator. Remember, we don't care about the top. Top's not important. Top can be 0 all at once. But the bottom, that's where we have problems. So this is a quadratic. It's already been factored for us. And if this bracket, the left bracket here, is 0, then it doesn't matter what the right bracket is. The whole denominator is going to be 0. Because it's 0 times a number that's 0. So we have to restrict for the left bracket being 0. And we have to restrict for the right bracket being 0 by the same argument. So if the right bracket's 0, it doesn't matter what the left one is. It's something times 0 is 0, can't divide by 0. So let's rearrange both these. So y minus 3 can't equal 0. So y cannot be 3. That's one of our restrictions. And our other one is y cannot be negative 4, just by rearranging this one. So those are our two restrictions. Restrictions. Y cannot be 3. And if we're listing multiple ones, we could just separate them by commas, or negative 4. Okay. Let's look at this next one over here, number 3. So here we have the same concept as question 2, where there's two things multiplying, neither of which can be 0, because if one of them's 0 and they're multiplying, then the whole thing's going to be 0. So one of them is 3x cannot equal 0. And if we want to rearrange this one, divide both sides by 3, x cannot be 0. Okay, because we get 3 times 0 times whatever is 0. Denominator 0. That's a problem. Okay. This other one, we take the whole bracket. So 2x plus 3 cannot equal 0. To rearrange this one, we always want to do reverse BEDMAS. So we want to move the addition subtraction first, then deal with the multiplication division. And then we would deal with like exponents and brackets and stuff like that, if there were any. So in this case, we'd get 2x cannot equal negative 3. Divide both sides by 2. We get x cannot equal negative 3 over 2. Sorry, 2. And that's our restriction for this one. So restrictions are x cannot equal 0 or negative 3 over 2. All right, for this next one, looks a little different. And for the denominator here, we can't just say, oh, x squared can't be 0, or, oh, 3x can't be 0, because they aren't multiplying. So we need to rewrite this as some sort of multiplication, and to do that, we're going to need to factor. So in this case, it looks like we can common factor. So let's start by rewriting this. So the numerator stays the same, 5 over, and let's factor. What can we factor out of here? I think we can factor an x. So x plus 3. Okay, now this question's very similar to the last question. So we have two restrictions. X cannot be 0. And by now, you're probably kind of getting used to it. And you might not need to write out the entire process for solving these. So this one, x can't be negative 3. So we can just skip ahead to that step if you're comfortable with that. So let's write that these are the restrictions. All right. Let's take a look at number 5 here. So it looks like we have an entire quadratic on the bottom, in the denominator. So we're going to have to factor that. So let's rearrange this one before we try to find the restrictions. So x plus 17 over, and we want to factor. So in this case, we need to, maybe we'll write it off to the side. We need to add to 3, multiply to negative 18. You might want to pause, try to figure that out, just get some practice. So that's going to be 6 and negative 3. All right. And the a value is 1, so we don't need to do decomposition. Okay, so what's our restriction here? So our restrictions, x cannot equal. So from the left bracket, it can't equal negative 6. From the right bracket, it cannot equal positive 3. Once again, to remind you, we don't care that a negative 17 will make the top 0. That's fine. You can have a 0 on the top, as long as you don't have a 0 on the bottom. Because once again, we can't divide by 0. Okay, once again, I think we're going to need a factor here. So let's take a look. We need two numbers that add to, let's see, I'll write it way over here. Add to negative 1, multiply to negative 6. So once again, if you want to pause to figure it out, go right ahead. Leave our numerators still there. And on the bottom, we're going to get negative 3 and x plus 2. Okay, so you may notice that we have an x minus 3 on the top and on the bottom. And in our next lesson, we'll talk about what we would do from there to simplify this rational function further. But for now, we're just going to leave it, and we're just going to work on stating our restrictions. So here are restrictions. are going to be x cannot be, see, positive 3 from the left bracket. From the right bracket, negative 2. All right, one more here. So I think we're going to have to factor this one out as well. Now, this is a special type of thing to be factored, but you do not need any special technique to do it. So if you think you remember how to do it, or if you want to try on your own, just pause the video and give that a try. So this is the special way to do it is called difference of squares. And I'll talk about that, but you don't need to know that it's difference of squares to factor this. So let's pretend we don't know what it's difference of squares. Then in order to factor this, it's easiest to rewrite this for a second. Or you don't even need to rewrite it, but as 0x minus 9. So we need two numbers that add to 0 and multiply to negative 9. And you can think about that for a minute. And that would just be x over positive 3 and negative 3. So x plus 3, x minus 3. Okay, now the trick thing is called difference of squares. So note that 9 is a perfect square, and so is x squared is a perfect square. And they're subtracting, hence difference. It's like a fancy math word for subtraction. So difference of squares tells us that you would always get the square root of the first plus the square root of the second. So x plus 3, which we got down here, times, and then the square root of the first minus the square root of the second, so x minus 9. Okay, anyways, we've factored now, so let's state our restrictions. So restrictions. Okay, so from the left bracket, x can't be negative 3. From the right bracket, it cannot be positive 3. All right, and that's all for this lesson.